Very good morning. Today, we're going to see about the how the nuclear waste is being disposed into the environment. What are the effects of nuclear radiation? Like that, we are going to see in the today's class. So, before starting, just an introduction to the nuclear power plants. The consumption, we have already discussed enough about the introduction and all. So just to refresh, like the consumption of electrical energy in residential, commercial, and industrial sector all over the world has increased in many folds. As you know, in the commercial sector and the industrial sectors, daily three-phase for commercial tariff connection, three-phase connection, and industrial sector, daily in that particular area, 10 applications. If you take area wise, even 10 applications are daily coming for commercial, those who wanted for commercial line and as well as the industrial line. So industrial sectors, it is ever increasing today in the world. You can't suspect this much load will be there for industrial sector, this much load will be there for commercial and even residential also. So we are building the new houses yearly. We are buying the new houses. We are going for electricity connections and all. So daily it has been increased, and coal and natural gas and oil provide for the most of the world's energy. So these are the most of the energy that provides the energy to the world, that is coal, natural gas, and oil. Petroleum currently accounts for 40% of world's energy. Natural gas provides 24%, and the coal provides about 26% of the world's energy and generates about 37% of the world electricity. So these are the percentage in which petroleum, then natural gas, and as well as coal provides the whole energy. Since the fossil fuels are a natural source, there will be eventually the shortage of them in near future. The International Energy Agency is predicting oil to run out by year 2020 with the increased demand and global economic expanse. Some predictions. So predicting oil to run out by year 2020, but still it has been there for another 20 to 30 years. We can rely on the oil. Around the 2050, it has been expected. After that, so some other way we have to choose. So some prediction expect an oil supply crisis sometimes within next 2 decades. After 20 years, we'll get a huge oil crisis when global demand will exceed the oil supply. Natural gas is expected to remain up to 65 years more, and the coal supply to last up to 200 years at the current consumption rate. With the increase in population increasing to predicted by 8 billion by year 2050, the end could be sooner. So after 2050, there might be not any coal resources, maybe that, but very few. So after that, we have to rely on some other technology. And here we are going to see the adverse effects of fossil fuel. So fossil fuel greenhouse gases are among major contributors to the problem of global warming. Not only burning of fossil fuel damages the environment, but every stage in the production of fossil fuel also exposes the environment to potential harm. For example, at the drill site, if you see like mining drill site, some leakages will be there. While we extracting the natural gases, some leakages will be there. and also oil while extracting also will get some leakages, and spill may infiltrate the groundwater. So groundwater, it will okay, it will easily pollute the groundwater. So those who are staying near to that drill sites or mining areas, so they will get the oil mixed groundwater. So if you see like wells and all, so those who are drinking water or consuming water from the wells, they will feel like some oil content also in that wells. So if you just put a fire onto that water, so it will easily catch fire also. So what they will do is they will filter that well water to some stages, and they may be using. And even if you see those who are situated near to that agriculture areas, so there also they will not cultivate some major crops. So why? Because due to the uh, like um, like uh, due to the um, contamination of that like oil or coal inside that water. So that also will um, leads to the damages to the crops also. Sometimes the crops like that, many things are there. Those are situated near to the agriculture fields. At the refinery, more toxic leakage occurs. Local gas station and boating docks contributes additional spills. Vaporization and underground tank leakages add even more chemicals to the environment. So, many pipes also will be they are taking oils from the delta areas. So what they will do is they will take many pipes. Okay, that pipes carries oils. So that pipes will travel for 500 kilometers, 1,000 kilometers, 2,000 kilometers, and all. That pipes will travel. So in that, whatever simple leakages happen in that pipes, or even like natural gases they are taking, and what they are doing is they are simply laying very huge pipes. In that pipes, they are taking that natural gases to that refinery areas. So in that, what happens is simple leakages happen also will catch us easily fire in that particular area. So if you see if you see like news and all, in some of the areas, you'll be finding simply the fire will be happening in the ground level itself. So because of that leakages in the pipes, so it will simply catches the fires, and also it will spoil the atmosphere near to that areas 20-30 kilometers. If you see it will easily pollute that areas. It will pollute the water, it will pollute the air, many things are there. And of course, automobile exhaust gases pollute the air and contribute to the respiratory ailments, such as increasing level of asthma in children. Like if you see the country the Union Territory of Delhi, so recently 1 year back there was a very huge like pollution happened in the Delhi near areas. So due to near to the Uttar Pradesh areas, that farmers simply like that they are burning their like wastage agriculture material, agriculture waste like that. So due to that, the whole Delhi, so 80% of Delhi got polluted, and the people living in Delhi, what they did is they bought some air purifiers and all they bought, and inside the home and inside the offices they are using that air purifiers, so that the air gets purified, and it will produce the pure oxygen, so that they can easily inhale. So like that and all pollutants are happening, and due to the automobile exhaust also, it will pollute. So those who are those who are staying in like cosmopolitan cities like that, so they will be feeling like a little bit asthma. Even children's also they will be feeling like asthma, and even some respiratory diseases, and they will feel like somewhat they will inhale some this pollutants also. So that also happening in many of the cities. So those who are staying outskirts of the cities, they are also inhaling, but comparatively less.
995. Number 995.
78 new years. Yeah. Next, motor vehicles. Motor vehicles account for 50% of all hazardous air pollutants and about 90% of carbon monoxide found in the air. So due to this motor vehicle also, you'll be finding some 50% of hazardous air pollutants are there, and also 90% of carbon monoxide also produced from the this motor vehicles. So that's why all the governments all over the countries, they are insisting more to utilize this electrical vehicles. They are slowly they are planning to eradicate this motor vehicles by after 20 to 30 years. They are planning to close all this motor vehicles, and in some countries they are severely imposing some tax on the motor vehicles also. So they should not use the motor vehicles more than 15 years. So 15 years, more than 15 years, if you are using that, they are keeping like 30 to 40% of tax. You have to pay 30 to 40% of tax more than that 15 years, and also you need to get like FCs for the vehicles, and also you need to pay 30 to 40% of tax so that you can run that motor vehicles for further 5 years, like that they are planning. So why they are imposing that much tax? In the sense, they want to they want to eradicate all this motor vehicles, using the petrol, diesel, and all. So they want to use some electrical vehicles. They want to use more the electrical vehicles, like the countries like Germany, Russia, they are in UK. They are planning for more electrical vehicles rather than motor vehicles. Even now, they are giving so government itself giving some subsidy for buying the electrical vehicles also. In countries like India also, they are planning to give the subsidies also. And tax also nil tax if you are buying and registering that vehicle. So tax is nil, and in some countries they are charging very minimum tax even for that. And also burning of fossil fuels causes air pollution. Pollution is the smog. We see some over cities as well as airborne contaminants that are not visible to naked eye also. So in 1 year before and all in Delhi, if you see like you can't even travel in roads itself. You can't even travel in roads because of the smog. And also they are keeping the lights even in daytime to run the vehicle, and they have to run the vehicle in 20 kilometers per hour and 30 kilometers per hour. If it exceed now, they are keeping the fine. And also some schemes also will be announced by the Delhi government, like 1 series and like odd series, even series, like that. They have to run the vehicle in the alternative days, like that. So if you run like that, if you run odd series in 1 day, and if you run even series in 1 day, so you're not following that thing, you'll be fined like anything, like that. Also, the government has planned for that. So these contaminants can make you sick and burn your eyes, nose, and even give you itchy, irritated throat and cause trouble with your breathing. So, like lorry drivers, motor vehicle drivers, they will be running their vehicle for more than 18 hours in hours in a day. So they will be cause this diseases like airborne diseases and the naked eyes, and also burn your eyes. It will cause burning in your eyes and nose, and also itchy feeling and the throat irritated like that. They will be feeling, and if you see the average life of the drivers, like 60, they will not cross more than 60, 65 like that. So they will be like they will got soon lung cancer like that and all they will be getting. So even with the no cause, they will be getting lung cancer after 60 years, 50 years like. So due to this only, so they will be traveling this air pollution for more than 18 hours in a day. In a month, if you see like 20 days, they will run that vehicle. So 20 days, they will run the vehicle for more than 18 hours in a day means definitely they will get a cancer. And chemicals in polluted air also cause cancer, brain and nerve damages, and also birth defects, lung injury, breathing problems they will get, and also air pollution. Air pollution harms the environment and also the people and animals and forests, streams, lakes, and it will affect the human beings. Animals also will be affecting, and the forest also will be eradicating, and the streams, lakes, and all will be reducing their size, and also residential areas also will be decreasing in that particular area. Like that, and all many things are there. So that's why those who are staying in like cities, they will buy the houses outskirt of the city. So they will be staying like 15 kilometers far, 30 kilometers far away from the city. So just like that, they will come to the city and they will work, and they will go to the residential areas apart from the cities. Like that, also they are planning the like most populated cities. Then, what are the pros and cons of the nuclear power generation? So for this now, so nuclear power generation is somewhat good when compared to these fossil fuels. So there are some pros and cons of this nuclear power generation. So the very first thing is that nuclear fuel is inexpensive, more abundant than the fossil fuels, and also easy to transport because you need to carry only like 1 kg to maximum of 5 kg, 10 kg like that. So not more than that. So simply 10 kilogram only you need to carry the fuel for even 1 year. Like so the energy generated is very efficient and the remaining waste is compact. And also, nuclear reactors need little fuel, and it must only be changed approximately once every 3 years. Every 3 years. So once it has been started now, after 3 years only, you need to refill that fuels, and that is also there. The amount of waste produced is billions of times smaller than the volume of waste produced from the coal burning plant. Nuclear reactors are safe in comparison to fossil fuel methods. Every year, about 50,000 people die due to respiratory illness in years caused by burning of coal. The chance of nuclear accident that would cause that kind of damage to human life is 1 in every 2. First of all, it is clean source of energy because it does not contribute to the greenhouse effect or acid rain like that. So whereas in fossil fuels, that might be causing the greenhouse effect, and also it will cause the acid rain once in a year like that. It will cause the acid rain also will be happening. And also, if you see like if you take like nuclear fuel, So once that accidents will be happening once in 250 years, once in a 250 years, like that average. But suddenly, if any accident happens suddenly, na, so like as I said, like the whole the country will be going 50 years back, 50 years back. So we have to start our life from before 50 years. So that also that if it is not happening, we'll be very happy, we'll generating the power from that, but still the radiation effect is there. So the main limitations is like, even though the cost of fuel is low, the actual cost of producing energy is higher than the forms of energy because of emergency and also containment and radioactive waste storage system. So here, radioactive waste storage system is very difficult, very difficult, and also after waste management system, if any radioactive coming out from that thing, so it will be injured like anything. And also high level radioactive waste must be stored in underground contaminant permanent containment permanent. So underground, we have to dig. Okay, we have to go inside the sea for 30 kilometers, 40 kilometers, and we have to dig the pit for around 10 kilometers, 20 kilometers deep inside the sea, and we have to store that radioactive waste, radioactive material, so that it will not emit any radioactive. It will emit, but even though the emission will be of very low, so it must be remain deep below the surface of the earth for millions of years. So millions of years, you have to restore that radioactive materials. So until it loses the radioactivity. So even though after 3 years, once nuclear fission is being, that is nuclear radioactive materials is being bombarded. So after the 3 years, it might be losing that level of the radiations, radiation. So even though some radiation will be coming out, so even for million years, that radiation effect will be coming out. So even you have to locate that particular place where it might be it might be restored. So and even if you see like even after million years, also some small radiation might be coming out from that materials. So now we are using uranium and thorium are mostly used fuel in the nuclear reactors. The mining of uranium itself causes severe problems in the environment. So even mining also causes serious problem in the environment and to the people living near to the mining site. During mining, large amount of air contaminated with the radon and dust are blown into the open air, which increases the level of radon concentrations. Okay, so those who are staying near to that mining of the uranium, so those people also will be affected with the air contaminated dust and the radon like that also will be coming to that air. So that also will cause some lung cancers increase in that particular areas. And also groundwater from that mines contaminates rivers and lakes. Okay, so on groundwaters, if you take like that, groundwaters also have some radiation. So with that radiation also will be affecting your those who are those who are intaking that water as a like drinking water and all will be affecting your lungs and some other organs also. So that also we will be very careful. So 30 kilometers and within that range, 30-kilometer range. So you should not stay even the mining site also, and even the nuclear reactors also. 30-kilometer range, you have to be you have to avoid staying near to that uh, 30-kilometer. Also will be affecting, and also nearby rivers, lakes. So like many species are living in the near in rivers, lakes and all. So that also will be affecting, and those who are intaking that species, those who are intaking that fishes also will be affected. So that also there. So you will be, you have to be very careful. Those who are staying near to that mining area, and as well as those who are staying near to the nuclear reactor. And also the meltdown of the reactor not only causes severe immediate danger, it also uh, contaminate the areas for years after the disaster. So simply like that, any accident, any meltdown happening in the reactor. So as I said, what they will do is they will simply close all that reactor. They will simply close the reactor for even 5 years, 10 years, like that. They will not open that reactor. They will not generate from that reactor itself. They will close with NaCl, sodium chloride, and all for some years, 10 years, 20 years, and all. They will not open that reactor, and they will not go inside, go near to that reactor for some years also. Once that plant is closed, that is being closed only. So they will construct new reactor somewhat far away from that places, and also increase the incidence of thyroid cancer. Thyroid cancers, along with numerous other serious health problems, accompany nuclear meltdown. So if any meltdown happens, also it will be causes thyroid cancers and some other health problems also. Crops grown near to the end can contain high level of radioactive elements. High level of radioactive elements. Fish population, as I said, fish population in nearby lakes cannot regenerate, etc. It is even hypothesized that a properly functioning of reactor also can emit a toxic level of radioactive to the population in the surrounding areas. So we have to note down this point. That is, it is even hypothesized that a properly functioning reactor can emit toxic level, of radioactivity to a population in the surrounding area. So in the surrounding area also, you'll be getting that radioactive substance. And also this also will be affecting the fish populations also. So those who are consuming that fish also will be affecting. So if breeding the fish in the lake also, you can't breed the fish due to that radioactivity. You can't breed the fish. So even you can put a fish inside that lake also, it will not grow, and you can't breed the fish inside that near to that lake also. Lake also, and also economics. I think this we have seen earlier itself, economics and all. Next, description of fuel sources also we have seen. Then types of reactor also we have seen. Types of core used, like homogeneous reactor, heterogeneous reactor, moderator used, graphite reactors, beryllium reactors, light water, ordinary reactors, heavy water reactors. Next, the coolant used, ordinary water cooled reactors, heavy water cooled reactors, gas cooled reactors, liquid metal cooled reactors, organic liquid cooled reactors. So majorly they are relying on heavy water reactors and ordinary water cooled reactors, because gas cooled reactors again the cost might be increasing, and also liquid metal also sometimes they are using in pressurized PWR. They are using liquid metal cooled reactors. Then organic liquid cooled reactors also. These are the types. Next, neutron energy reactors, thermal reactors, fast reactors. Next is fuel material used like enriched uranium, natural uranium, plutonium, thorium, and all. So if you are using like natural uranium, plutonium, thorium, so you have to rely on fast breeder reactor. So if you are using normal enriched uranium, you can go for PWR, that is pressurized water reactor, or BWR, boiling water reactor. So due to some limitations, we are not relying on boiler water reactor. Only we are going for pressurized water reactor. So in some other class, we will see what are the reactors used in different parts in our country, India. That we will see in the different class. This thing and all we have already discussed. PWR, pressurized water reactor, we have already discussed this, in detail. Same thing is being repeated. So next, what are the main advantage of this pressurized water reactor? Is like it is cheap as ordinary water. Why? Because ordinary water is being used as a moderator and coolant, and it is very compact in size when compared to other reactors. And the power density of reactor also will be relatively high. And there is a possibility of breeding plutonium by providing a blanket of uranium-238. That is the main advantages. And also, reactor takes care of load variation by using the pressurizer and surge tank. So if the load might be increasing, the automatically feedback is being given to the pressurizer, so that the water pressure will be of more, and so that the power being generated will be increasing. And the major disadvantages is in the sense low thermal efficiency, approximately 20%, whereas in coal power generating units it is approximately 30%. Here it is 20%, and also greater heat loss due to the use of heat exchanger. So in the heat exchanger, somewhat heat loss is happening. So that heat loss only we are utilizing for boiling the water. And also due to the high pressure, a strong pressurized valve is required. So strong pressure valve is being required, and also frequent maintenance of that pressure valve vessel also will be required. And also there is lack of flexibility in recharging the fuel, and also more safety devices required. Devices required. Those who are working in that unit, that is PWR unit, more safety devices being required. And also expensive cladding material is required to in the boiler. So the boiler, some cladding material will be there. I think already you have studied in your chemistry what is the cladding material. So like expensive cladding material might be required in that particular boiler to avoid the corrosion. So these are the disadvantages in the PWR. Coming to the fast breeder reactor, FBR, fast breeder reactor. So this fast breeder reactor, based on the neutron flux spectrum, reactors are classified as thermal reactors and as well as fast breeder reactors. The main advantages of this thermal reactors can ease in control. So control will be very easy, and also greater inherent safety, and more heat generated per unit volume of the core compared to the fast breeder reactors. On the other hand, thermal reactors pose some limitations such as choice of fuel is very much restricted in the case of uranium. And secondly, size and weight of reactor per unit power output is higher. More fissile material is consumed. More fissile material is being consumed here in this type of thermal reactor. And also, if you take like fast breeder reactor converts more fertile material to fissile material. So converts more fertile material to fissile material, and therefore fuel consumption is less. So fertile material of uranium to fissile material. So it can be easily converts that fertile material to fissile material. But in this fast breeder, if you take like some three-stage, you need some three-stage of reactors might be required. Why? Because directly you are taking fertile material and we are converting that fissile material. So for that converting fertile material to fissile material, so you need some three-stage thing to change that fertile material to fissile material. So most produced fissile is plutonium from the fertile uranium-238. So you can convert uranium-238 to this plutonium. The fuel rod in core region does contain the mixture of fissile plutonium-238 and uranium-238. The active core region is surrounded by a blanket of fertile 238. Fertile 238. This region captures neutron that would otherwise be lost through leakage, thus producing additional fissile material. So this causes additional fissile material. And a coolant with excellent heat transfer properties is required to minimize the temperature drop from the fuel surface to the coolant, and also it must be non-moderate. This rules out the water and best coolants for the fast breeder are required liquid metals such as sodium, Na. Such reactors are also called liquid metal cooled reactors. So the coolant also will be used. That also we have to choose the better coolant so that the heat transfer properties also will be required to minimize. So sometimes like heat transfer is required to minimize the temperature drop from the fuel surface to the coolant. So and also it might be non-moderating also. So such reactors also is called liquid metal cooled reactors, that is LCMR. So due to the induced radioactive of liquid sodium, an intermediate loop such as Na or NaK, okay, NaK as a coolant between this primary radioactive coolant and the steam cycle is required. So therefore, there is a need of two heat exchangers. So two heat exchangers might be there. So in that, due to this two heat exchangers, so there is a possibility of losing the heat also sometimes. The primary loop design can be either pool type or loop type. In the pool type, the reactor core primary pumps, then the intermediate heat exchanger are placed in the large pools of sodium, liquid sodium contained reactor vessel, whereas in the loop type system, all are placed outside the vessel, or are placed outside the vessel. So here, if you see that figure 7.9, it shows the liquid metal fast breeder, that is LMFBR. Okay, so here the reactor is there. So again, two-stage heat exchanger is there. So one stage. So here, sodium is used as a like a heat exchanger. Okay, coolant. So in that coolant will be here extracting the heat in the first stage. So again, it is being taken into the second stage. So again, the heat is being extracted. So with this, we are pumping the water inside the so that the water is being okay, pumped. So water is being stored uh, converted to the steam, and that the superheated steam we are taking that to the turbine, and this water is being pumped into the steam, and also this sodium also being pumped into the this heat exchanger again and again, so that you can extract more heat from the reactor. So in this some advantages also that sometimes the heat due to this heat exchanger, so you might be losing the heat also. So and also more heat also, um, like the steam turbine will be rated of like alternator will be rated of 1000 megawatt or 1500 megawatt. If more heat generated, if more heat generated also, it will be damaging the turbine, so more superheated steam will be generated. So in that time, in the reactor, so moderator might be used to reduce the fission reaction, so that the heat produced from that reactor also will be automatically reducing. So that also that. And so major thing, the effects of radiation on human being and the biosphere. So this is very, very important while constructing the nuclear power plant. So radiation. So generally, if you see radiation refers to the frequency of the electromagnetic spectrum related to electromagnetic radiation. So radiation is nothing but the frequency of electromagnetic spectrum related to electromagnetic radiation. So this is the emission of energy throughout the space in the form of the waves. So this radiation is not an anthropogenic process. Natural background radiation is emitted from the radioactive chemicals that are naturally occurring, such as uranium, radon, potassium, and other elements. Radiation is sometimes referred to as alpha, beta, and gamma radiation. And this uranium itself does not contain much radioactive material, but it might be carefully handled in the mining process. Most of the these are the radioactive chemicals, that is radiation that is coming out of the that nuclear power station, that is uranium, radon, potassium, etc. And also sometimes alpha, beta, gamma radiation also will be coming out, and it causes severe effect from that. So even though the reactor is being closed inside that reactor, even though some radiation will be coming out from that fuel, so that it will be affecting it will be low effect will be there, those who are staying near to that nuclear power station. Uranium itself does not contain much radiative element, but it might be carefully handled in the mining process. So most of the radioactive materials is left to the tailings after the uranium is extracted and never goes into the fuel. Small or natural dose of radiation are not harmful to the humans or biosphere. A dose of 100 milli or REMS. So this is that radiation units. So 100 milli REMS, 100 milli REMS per year is considered to be average human exposure. A dose over 200 milli REM at all once it could cause radiation sickness. So above 200 milli REM will be causes some sickness, such as mining and using it into the fission reaction process. Through these activities, radioactive chemicals are introduced to the food, air, and water. So, and also it is directly this radioactive materials, that is radioactive radiations that is coming out, it will be directly introduced to food, air, and water. So it will be, we are taking that food, air and water easily, so that it will be affecting our organs also. So easily we'll get, with the no cost, we'll easily get lung cancer, we'll easily get the cancers, stomach cancer, skin cancers, like that, without no cost. Like if you take like radioactive fission products are the variant of ordinary chemical or introduced in the nuclear reactors, and it's also possible for the fission chain reaction to form the activation products, which can leading to the contaminations. So here also, if you see like as a turn normal states over hundred of thousands of years, they release ionizing radiation. So this like radioactive materials, after 3 years or 5 years, so it will cause like emissions for even hundreds and thousands of years. So slowly it will release ionizing radiations. So gamma radiation is released from the isotopes of bismuth and lead. They can be toxic to the kidney if it build up and but are usually released to the urine. Usually released to the urine, and those who are handling this bismuth and lead acid batteries and all, those who are working in battery companies and all, they will be affected with the kidney failure and all will be happening with the no cause. Okay, after 60 years or 50 years, simply like that, they will be getting, they will be causing kidney failure like that. So if you take the history of where they worked previously like that and all, so they might be worked in the like battery manufacturing companies and all, so they will be affecting. And also as a radon decays, it's emit alpha radiation. Radon gas is released during the mining of uranium. Alpha particle does not normally penetrate to the human skin, but they can damage the skin. It can damage the skin easily if they enter to the body through ingesting, inhaling, or absorbing radioactive chemicals. They can cause serious damage to the organs. With no cause, organ damage will be there, and easily you can get the organ failure deaths and all. For example, if alpha particles or beta particles discharge in the lungs, they can cause lung cancer. They can attach to the bone also. So bone marrow, like the bone cancer also will be there. It is also called leukemia. This is why it is harmful to have our water, food, and air in contact with these materials. And also those who are working, those are working inside the nuclear reactors. So they will be staying 30 kilometers, 40 kilometers far from that reactors. So generally they will travel that 30 kilometers to that particular nuclear station, then they will come back. So because radiation will be there, some small amount of radiation will be there in and around 30 kilometers range. So that also they will be staying away from that range also. And also safe disposal of radioactive waste. So after the fuel in the rod has gone out the fission process, these rods are said to be spent. Okay. So what they will do is, since they emit the gamma radiation, thus must not come in contact with the biosphere. So they are shielded with water and thick water lead walls. So thick lead walls they might be keeping, and they will be placing into the deep seas, into the underground water, so that that will not be coming out. If they were come into the contact with the humans, they certain death also. These fuel rods must go through a process to remove the radiation. The outer cladding outer cladding dissolved in nitric acid, and radioactive debris is stored in the liquid form. The large is dissolved in the nitric acid, and the radioactive debris is stored in the large carbon or stainless steel drums. In the stainless steel drums, it is being placed, and after it solidifies, it is permanently buried. Waste of lower radioactive is buried in dirt trench or pumped out to the seas. This is not hazardous because this waste of is, even though it is not hazardous, but some gamma radiation will be coming out from that thing. So over time, nuclear power plant becomes contaminated, even though most of the fission fragments are safely kept inside the fuel rods. Activation products are formed in the air, water, and pipes of the buildings, and plant eventually becomes unstable. It is then deactivated and or mishandled or disposed of as radioactive waste. And radioactive waste in the mining process is contaminated in a dam. The solid that remains after the uranium is extracted, called tailings. They are pumped out slurry to especially engineered dam to retain them securely. Okay, so that also the, and still in the Second World War, they have used that nuclear weapons and all, no? So nuclear bombs and all. Still, that nuclear bombs are still it is there in the deep seas. It is emitting some okay, radioactive like um, um, materials, radioactive things, and still it is emitting, but it is not affecting. It is not severely affecting, but still it is that radioactive materials is being coming out from that thing. So that also that still, but even sometimes that nuclear like that bombs materials is coming out to that seashores like that. So it will it will cause, it will emit small radiation, but it will not affect humans. But even though some emissions is still after like 60 years, 60, 70 years, still